In 11-2, you guys are going to learn how to multiply and divide rational expressions. Now, it's really not different from yesterday. You're just going to have to remember with multiplying, you combine everything at the end, and with dividing, you flip, and then you combine. So it's really not a lot different than anything you've been seeing so far. Let's just go ahead and jump right into it. Problem 1. 6 over a squared times negative 2 over a cubed. You see if it's at possible to cancel if you can. Now, how can you cancel? Maybe we should talk about that. You can cancel up and down, or you can cross cancel. Alright, that's really it. You can cross cancel and you can cancel up and down. So what I'm going to do is let's look at this problem. Nothing cancels up and down, and nothing cross cancels. Notice I did not say side by side. You cannot cancel side by side. So what's the final answer? Negative 12 over a to the, well, when it looks like this, you add your exponents, a to the 5th. That's all there is to it. What can't a equal? A cannot equal 0 because that would make your denominator 0. Okay, and that comes from yesterday. Number 1, the got it. What's the product? Take a look. Does anything cancel? No. So your problem is 15 over y to the 4th. That's it. Unless that's a v. If that's a v, it's a v, but it seems like a y to me. Y is not allowed to be 0. Look at part B. Notice everything's already factored. It's nice binomials to work with. What's the product? X times x plus 1 over x minus 2 times x minus 3. You could multiply all that stuff together, but I would just have you undo it here coming up anyway. So what can x not equal? X cannot equal a positive 2 or a positive 3 because then your denominator would be 0. So not too bad so far. Moving on to problem 2. What is the product? Now what we need to do is take a look at the title. You need to factor. The top left stays x plus 5. The bottom left, you should see, you pull out a 7. You get x minus 3. Now up here, 14x remains 14x, and down here, this bottom is a trinomial which factors into two binomials. You got x and x. 10 is made up of 5 and 2, and you need a positive 3, so positive 5 minus 2. What I'm going to do here is I'm going to take a look at your excluded values. It doesn't ask for it, but we may as well practice. Your excluded values are when x minus 3 cannot be 0, and when x plus 5 can't be 0, and when x minus 2 can't be 0. I'm just putting the things from your denominators here. Therefore, x cannot be a positive 3, a negative 5, or a positive 2. Let's move on and cancel what we can cancel. Notice that you can cancel the binomial x plus 5 with the binomial x plus 5. Notice you can also cancel the monomial 14 with the monomial of 7, 14 becoming a 2. Do not try to cancel this x with any of the other x's. This x is a monomial. These x's are part of binomials. Your final answer is 2x over x minus 3 times x minus 2. And that's all you can do. The 2 doesn't cancel because one's a monomial and one's a binomial. Let's try one more time. We got more factoring to do. The top left does not factor. The bottom left does not factor. Bring it down. Times. The top right factors. The bottom right does not. X and x, 2 and 1, both are plus. Can you see how important it is for you to be able to factor? Monomials with monomials, binomials with binomials. X plus 2, x plus 2. A binomial with a binomial. X squared with x. There's 1 on the bottom, 2 on the top. That leaves 1 on the top. I would ask you guys, where's the party at? Carry over what didn't cancel. That would be a 3x to the first, or 3x, with an x plus 1. All over, nothing. If you wanted to state your excluded values, it doesn't ask for it, you would say from this one, x can't be negative 2, and from this one, x can't be 0. Part B. In problem 2, suppose you multiply the numerators and the denominators before you factor. Will you get the same product? Well, the answer is yes, but the factoring would be next to impossible for you guys right now. So you would probably get it wrong if you didn't factor first. Okay, don't wait to factor until the end, because really if you wait to factor until the end, you're really going to hurt yourself in the long run. Factor first, then smush things together. Problem 3. In problem 3, you need to understand that you can also multiply a rational expression by a polynomial. And you're going to leave the product in factored form, which is what you guys have been practicing anyway. When you multiply here, all I need you to do is the second one, here's what they're saying. It's technically over 1. Don't make it more difficult than it is. The top left doesn't factor. The bottom left does factor. The bottom left, you can pull out a 3. Always look for that GCF if you can. So you get 3 times m minus 2. Times the top right is a binomial, 2 binomials, m and m, 2 and 3. The 3 is a plus and the 2 is the minus to get the plus one you need. And that's all over a 1. So they're just saying you can take a rational expression, multiply it by a polynomial, that would be over 1. Cancel what you can. I see an m minus 2 here and an m minus 2 here. That's all that cancels. I end up with 2m plus 5 times m plus 3 on the numerator. In the denominator, I get a 3. Please don't try to cancel those 3's. The bottom one's a monomial, the top one's part of a binomial. Let's do the got it's. The got it's, we're going to just pretend, again, this is over 1. We're going to look for some GCS and factor the trinomials. Part A, top left, take out a 2. You get x minus 7. The bottom left, take out a 2 again. You will get 2x minus 3. Okay, I just used a GCF on those. Now talk about this top right. There's no GCF, so let's think of some factors of 6 and 6 that can make 13. We can use 2 and 3, we can use 6 and 1. However, take a moment, pause the video, and see what you can get as your factors. Okay, the final factor form, after you kind of play around with it and you know how to factor, just go ahead and use guess and check or do it the long way, whichever way you feel comfortable. Make sure that you get 3x minus 2 and 2x minus 3. If you use guess and check, that works because this is negative 9 and this is negative 4. Negative 9, negative 4 makes negative 13. All over 1. We're going to cancel what we can cancel. And can you guys notice that the bottom left is canceling with this top right? I probably could have helped myself out and at least tried this as one of the factors. Now one more thing that cancels are these monomials of 2. Write what you have left over. X minus 7, 3x minus 2, and it's really just over 1. So my final answer is x minus 7 times 3x minus 2. Part B, the factoring will be a little easier, I think. The top left will be x plus 1, x plus 1. If you don't understand that, pause the video, make sure you can figure it out. Now how does the bottom factor? You should see that that is a special case, x minus 1, x plus 1. Difference of perfect squares. You're going to have to go back to chapter 8 if you forget how to factor. top right, x plus 3, x minus 1. It gives me the plus 2 I need, and that's all over a 1. The x plus 1's cancel, the x minus 1's cancel. Notice you only get to cancel one of the x plus 1's on the top though. Okay, here I can color code it orange with orange. Okay, you're left with x plus 1 and x plus 3 on the top, and nothing left over on the bottom. So you write x plus 1, x plus 3. In problem 4, we talk about dividing. Now, dividing is really no different, okay? The only thing that's different is that you have to flip the second fraction, and then you just follow your rules for multiplying. Okay, so flip the second one, and then follow your multiplying rules. Let's take a look at the example that they have worked out for you. Here's the original problem. Notice in the next step, they flipped it. They flipped the second. Okay, you can do that. That comes from what? 5th grade when you guys learn how to divide fractions. This is just a more complicated fraction. Okay, notice in this step that they factored everything they could. Okay, they factored the difference of perfect squares. They took out a 4. They factored the trinomial. The bottom didn't factor. They canceled what they could cancel. And then last step is they just rewrite the final answer. Okay? Let's try a couple of these following kind of these exact same steps. Got it, 4a. I keep the first one as x over x plus y, and I multiply by x plus y over xy. I just flipped the second and changed it to multiplication. Okay, this one doesn't factor. They're all factored as much as they're going to get factored, so you're done with that. Now we need to cancel monomial with monomial, binomial with binomial. There's the binomial, and here's the monomial. X and x. The only thing you have left on the top, don't say 0, you have a 1 left in the top, because you always have something left over, and a y in the bottom. Let's try part B. Part B is a little harder. First thing, pull the flip. So we're just going to flip the second fraction. 9k minus 15 is now the numerator. K squared plus 6k plus 8 is the denominator. Now we need to factor this top. Factor the top left. You should pull out a 4. Factor the bottom left. You should pull out a 2. Factor the top right. You should pull out a 3. Factor the bottom right. You should be writing 2 binomials, k and k, and you should break down 8, positive 2 and positive 4. Next step, you need to cancel. So I see that I can cross cancel k plus 2 and k plus 2. 3k minus 5, 3k minus 5. 4 and 2, with the 4 becoming a 2. And that's it. Rewrite what you have. On the top, you have a 2 times a 3, makes 6. And on the bottom, you have a k plus 4. That's it.